Okay, great. Let's get started. First off, thank you for coming out so early after the data night out. Appreciate that. So we're going to be talking about how Wayfair blends two different data sources to serve the need of providing both real-time and historical context. So to start out, we're going to provide some context about kind of what is Wayfair, how do we use Tableau in general, some of the problems that presented, then get into how we fixed those, how that led to this particular solution, go through a local example of how that works, and then talk about what's next. So first off, who am I? Senior manager at Wayfair. I've been in the BI department there the whole time, started out making Tableau reports and spending a lot of time trying to make them faster. And I've now moved to trying to make everyone else's Tableau reports faster. So career progress. And Wayfair, if you're not familiar with it, maybe because you don't watch HGTV, we're an e-commerce site. We sell over 8 million home products, and we do that by partnering with over 10,000 suppliers that actually provide the goods. We provide the storefront, merchandising and advertising. We've been growing like crazy, so it's been an exciting journey. How do we use Tableau? So at Wayfair, there's two main installations of Tableau. We embed Tableau in an internal application called the Wayfair Analytics and Reporting Platform, where it's the primary source of reporting for a lot of our clickstream data sets. And then we also embed it into a supplier portal. The idea here is that we want our suppliers to do things better because that's better for us and better for them. So we provide information about things like shipping incidents, what customers are interested in to help them tailor their packaging and product selection, and we do that through Tableau reporting. Both those are server. And then we have a lot of Tableau desktop users across a variety of departments. It's very popular for just ad hoc data investigation, exploration, telling those data stories. When I started, we had about 200 users of our Tableau server and 10 developers. We were using the standard extract-based system. I think it's a pretty typical story. Over the last 3 years, that base kind of exploded. Today we have 1,500 users of our server installations internally and about 150 developers publishing reports. And along the way, we've really recognized the need to kind of build that culture of excellence, provide some resources for these 150 users to help make sure that we're scaling in the right way. So some quick history about Wayfair Tableau Conference. This is my first year here, but we've actually been here for the last 3 years. In 2015, we presented about the heat map there on the left, which is a way of kind of programmatically building these dashboards for every one of our web pages and mapping clicks onto them to help our site design staff kind of figure out what order things should be in and redesign those pages. And then last year, a shout out to Nathan back there, who actually presented on our analytics and reporting platform. And this year I'll be talking a little bit about the data behind that platform. So where we are today, since we primarily use Tableau for clickstream reporting, these end up being very large data sets. So just looking at tables in our data warehouse that are designed to run Tableau dashboards, we have about 25 terabytes of data, which comes out to about 1.1 trillion rows in total. And that's growing at a rate about 1 terabyte of data per month at this point. To handle that, we have a 5-node Tableau cluster that handles about 15K database queries for 7K dashboard loads. And what we communicate out to users is that we'll always provide 10-second or less load time for these dashboards. Don't always hit that, but that's the goal. And in terms of the latency of the data in these dashboards, for anything that's revenue sensitive, we target about 1 hour, and for other data sets, 24 hours. The idea there is not that we should catch something that's wrong with our site by someone staring at a dashboard, but when some other alert fires, we want to be able to provide that additional context for someone to dig in. So what do our users look like? Wayfair has always been a very data-driven company, which means we have great users in that they are very excited to get at our data. So they're very engaged. They're familiar with a lot of other products. They're not really satisfied unless they can get their hands on the raw data. They love Excel. And so they set a pretty high bar for us in terms of what we can deliver. And looking back about a year ago, what was working for us was a lot of the Tableau desktop and data exploration by people that were familiar with data. Those kind of ad hoc investigations and stories were very productive. We're adding a lot of value to the business. What wasn't really working is when we took some of that content, put it up on the server, and said, hey, this is going to be like a standard enterprise report. And the main reason there was just that things would take too long to load. So some context before we dive into that a little bit more is that we only use live connections. And that's a product of the volume of data. When you're trying to build extracts on 100 of million-row tables, it was just taking too long, putting a lot of strain on our server. So we made the decision to just focus on having our server provide the visualization and then push all that work of providing the data down to the databases. Obviously, this presents some challenges. We have contention with our ETL. We have concurrency concerns. So we use Vertica as our main data warehouse. It can deliver amazing performance on very complex queries, but generally not when you have 100 people trying to do that. And then this set a pretty high bar for analysts in terms of doing the right things on the database side so that the dashboards would perform well. And then we had the usual instances of, like, if the database goes down, there's no reporting available. With an extract-based solution, you don't have that kind of problem. So what we were seeing was that we had these demanding users that wanted very complex dashboards that could really let them drill down. And that was causing problems for our database. There's actually a ton of pretty simple things you can do to optimize. You can make custom TDC files, suppress a lot of those extra queries that are coming out of Tableau that might not be adding value, tune what Tableau does, set some resource limits there. So we did all of that. Then there's a lot of database-specific optimizations that you can do. If any of you work with Vertica and MemSQL, it's all pretty standard stuff. You can essentially optimize the data where it sits in the database for the queries that you're going to get. Both these are distributed databases, so avoiding joins or making sure that what you're joining on is distributed and sorted properly is pretty important. So we spent a lot of time on this, but it really wasn't enough. So the first step was to reduce the number of queries that were coming out of Tableau. And so we did this in Nathan's presentation by essentially using the JavaScript API to remove anything like quick filtering from our dashboards. We could figure out what were valid options for any of our reports, pull them out, provide a web application where the user would select that, pass the filters through the JavaScript API. So on a dashboard that had 20 quick filters potentially, one of those analytic dashboards that our users loved, instead of having 20 queries for all those filters and one for the view, we now just have the one query for the view. And then through kind of our best practices group and through this portal, we did a lot of work to kind of make reusable tables and components that could be mixed and matched between dashboards. This meant that there was less duplication of data and less things to optimize. We could kind of focus on these standard data sets and make sure that they performed as well as they could. Still, wasn't quite enough. So what we were really looking for was a way to take every single query that was coming out of Tableau server and handle it exactly the way we wanted to. And we needed to do this in a way that it didn't add any overhead to our 150 developers, no additional complexity for them. There was a wide range of technical abilities, and it didn't affect the end user experience at all. And ideally, we wanted to use this using technology that we already had within Wayfair. So what we had to work with was 4 key technologies in our BI stack. We use Redis a lot, just as a standard key value store. Vertica is our main data warehouse. That's where we take all the data that's come out of our data lake in Hadoop. Once it's processed, we stick it in there, and it feeds into all of our reporting solutions. We were experimenting with MemSQL as a solution to handle real-time streaming of data. It has great integration with systems like Kafka, very easy to stream stuff in, where Vertica had a bit more, struggled a bit more with that. And MemSQL also has great performance out of the box for anything that's in memory. So our goal there was to keep MemSQL entirely in memory, stream in the data, keep the size of what was in it pretty small, but have it serve that real-time reporting need. And then generally across our BI and data science departments, a lot of people are familiar with Python. So what we ended up doing is setting up kind of this middle layer of Python servers. And so these actually go to Tableau and say, hi, I'm a Postgres server. Believe me. And so Tableau obligingly sends some queries for a dashboard. The servers look at the query and say, all right, where does this data actually live? I'm going to run the query versus that database, get it back, package it up, send it back to Tableau. And then Redis is hooked into the Python server, where we essentially say, all right, if we've seen this query before and we've gotten the results back, we don't even need to go to the database. That result set's already there. And this was very easy for us to kind of build a POC and then scale out to meet the load that was put upon it. So how this works is that someone loads a dashboard in Tableau. Tableau fires off a bunch of queries. Those go to the servers. They say, all right, this data lives on Vertica. Let me check to see if there's a key for this query on Vertica that already exists in Redis. If there is, that's kind of the optimal path. We just grab the results, pass it back to Tableau. Database never even knows anything happened. Or if there's not, then put a key in there that says, hey, I'm running this query. Go run the query, get the results back, replace that key with the actual results, return the results to Tableau. And that key that says, hey, I'm running this query means that we can avoid ever running simultaneous queries against the database. Essentially, whichever, we have 10 users open up the same dashboard at the same time. Whichever query gets there first does the work, and the other queries just wait, and then grab the results after the database has returned it. So how does this actually work? Well, does it work? Did it meet our needs? So it did work in that we had what we wanted, which is essentially total control over the queries coming out of Tableau. For each one, we could do what we wanted, send back any results. And it also opened up a lot of possibilities in that where Tableau didn't have great native connection to things like graph databases, for example, we could kind of write our own layer that would translate queries that were coming out of Tableau into a query there, package it back up, send it back. And it also let us do a lot more things with resource management, where you could say, like, hey, this dashboard is a problem. Let's either suppress its queries or potentially change the user account it's running under without having to go in and edit the dashboard itself, which made it easy to automatically manage that. And then we can also kind of send back custom error messages for things. So if we have a scheduled maintenance, someone loads a dashboard, instead of that generic, couldn't connect, we can send back something that says, hey, we're doing maintenance, try again later. And then from the BI perspective, we're also most excited about it gives us a ton of visibility into what's coming out of Tableau, what's working, what isn't, which helps target our optimization efforts. So what doesn't work is that Tableau assumes it's talking to a database. And Tableau actually does a lot of really smart things in terms of testing the capability of databases, its own optimizations that don't always work as expected. So we have to spend some time lying to it about what the database is capable of. And then it's writing Postgres queries, which are close to Vertica, less close to MemSQL. So we actually have to have a layer in there that takes each query, rewrites it appropriately for where it's running. And then obviously there's extra management of this middleware layer and some queries that would be very fast. So say you're hitting a Microsoft SQL server that's well indexed, might take more time under the system because we're adding this whole middle layer in between. So let's talk a little bit more about caching, because that's kind of the key to enabling real-time streaming and historical data to work well together. The idea here is pretty simple. If you have a successful dashboard, successful in that people are getting insight out of it, they use it, it's going to get looked at a lot. And we really don't want to run the same query more than once if we're not getting any new results. Again, Tableau does a lot of really smart caching on its own, ranging from like images to query results. But the problem is that it has to be pretty conservative. It doesn't know anything about the state of the database, and you don't want to, if the database has changed, you don't want to show the user the wrong data. But we know that. So we're in a situation where we have these very large analytical queries that are getting summed up into a very small result set, revenue for some arbitrary subset of customers, for example. And from our ETL processes, we know when that table is actually being updated, so when the results of that would change. Putting that together, we can do this smarter caching where we can persist the keys for these queries up until the table actually gets updated. So in practice, we see about 55% of the queries that make it past Tableau's cache hit our cache. And then an additional 10% are duplicates of another query that's already running simultaneously. So again, those don't have to hit the database. So only 35% of the queries that are coming out of Tableau actually hit our database, which has obvious implications in terms of how big the database needs to be and the level of concurrency that we can support. And the best part about this system is, from the perspective of BI developers, there's no extra work required. If they use our ETL tools and they connect to this, they don't have to do any configuration. It's all handled automatically. So the second thing this lets us do is kind of arbitrarily combine data from different sources before it even gets to Tableau. So this is where the MemSQL and Vertica integration really happens. So we tell Tableau, hey, we have a single data source, this one table that you can connect to. When Tableau queries that, we actually run that query versus these two databases, concatenate the results, send it back to Tableau. There's some obvious potential data problems here with things like aggregations and distinct counts. We need to make sure that anything we're running under this system is something where we can just straight add the results together without it being incorrect. So we'll go into more detail about how we do that in just a bit. So again, a very important thing here is that this be totally unnoticeable to our developers and end users. And the way it's essentially been set up for a clickstream data source is that we'll have the last 48 hours in MemSQL, a very constrained data set, and then we provide the full historical data set in Vertica. So they come in, what they see is just that they can see from an hour ago back to the very first order in Wayfair on the same dashboard without realizing that they're actually interacting with two different systems. And most importantly, since providing the historical context is the expensive query, whereas the recent data that's in memory is very fast, we can cache those separately. So when we're updating the real-time data throughout the day, we don't have to go back and look at that historical data again. We can just assume that it's been static. In practice, we end up invalidating the real-time cache about every 15 minutes and then historical every 24 hours. Cool. So let's see how this actually works. First off, this is all fake data, obviously. And then in the interest of avoiding technical difficulties, this is entirely local. So I'm running an instance of Redis, an instance of the caching server. Because it's local, running Vertica and MemSQL wasn't feasible. So we're actually going to be working with a Postgres and a SQLite database. All right, so here we have a totally standard workbook. We're working with about, can't really see that, but it's about a 9 million row data set here of fake orders in the US. I'm now going to open up another workbook that is identical. except when I go into connect here, just going to add this additional query at the beginning, which tells our server not to use the cache at all for this workbook. And so here we're going to wait a little bit while it actually goes out and crunches all that data. So going back to the, should take about 30 seconds. And so the idea here is that this doesn't just help our end users. It actually helps our BI developers be a lot more productive. You spend a lot of time when you're working with a workbook just opening it up, waiting for those quick filter values to populate, all of that. If you're working with a common data source, most likely someone's already run that query. And so when you open up that workbook, it's very fast. We can just do one more quick comparison here. I'm just going to hit F5 repeatedly on both dashboards so we can see. There we go. And now let's do it over here. Okay, there we go. So refreshing on the left, and you're never actually going to see that. Well, there we go. All right, done. So you can see that, obviously, cache result sets come back a lot faster. And then from the development point of view, analysts treat this exactly like they would being connected to a normal database. So we can go in, drag and drop, and interact with it just like we would, just with the added benefit of if that query has been run before, it won't take any time at all. Apparently this one has not. Cool. Yep. So, going in and checking values and filters, all of that straightforward. You can change this to. So your experience as a user is exactly the same as if you were connect to the real database. Now, the second thing we do is bridge data between multiple sources. So once this finishes, we'll go take a look at that. So let's take a look. So in this data set, we have orders. I'm looking at the last 12 months, and we have data through December 31st, 2016, in Postgres. We also have a SQLite database that has much more recent order data. And so I'm actually going to go up here to columns and just switch this to be the exact date. And we can see that we now have this additional data over here. And so what's happening is that we had this previous problem with aggregates and distinct counts. So we can't actually combine data from these data sources unless we guarantee that they're grouping by the grain that we defined. So for each one of these connections, we say these two tables on two sources have this data, and the split between them is based upon this column. In this case, it's the completion date of the order. And so if there's a query that's coming through that is grouped by that, then we can safely combine the data. If there's a query that's coming through that's not, then we can't. So this is, from the analyst perspective, what they see is that essentially they'll have more data available when they're using that proper key. If they don't, it just doesn't show up. Yeah, so if we go in here and we look at individual times in this filter, this is Tableau fires this off as select date, group by date. So you can see that we have the recent data available. If we go back to the day, then We can't make that guarantee again anymore, so we're back to looking at just the limited data set. And so obviously, this can be a little bit confusing, but our primary concern is that we're never in a situation where we're providing incorrect information through the system. And then the last great thing is that we have a ton of information about what's coming through. So just looking at the last 48 hours of me messing around with this demo, the average duration of our uncached queries was about 10 seconds. Tableau doesn't actually let you do millisecond difference, which is, so all these cache queries show as 0 seconds, but it's usually somewhere in the 0 to 0.5 second range. And then just in typical work, putting together a dashboard, about 70% of the queries that I was running were actually hitting those cached result sets. Could drill down into it. Then the way our ETL is hooked in is that whenever we cache these, we store the table that it's associated with. So a query that's coming in that says, select the order date from table order, that's going to be associated with the order table. If we have something that's doing a join here for one of our more complex views, that'll be associated with both the order table and with, say, the state table. And so that way we know that if either of those tables is updated, we actually need to go in and invalidate all those keys. I can just do that by clicking this. That should. There we go. So I'm going to hook it up to our server through web service, and here we just deleted 75 of our cached keys. And now if I go back to this view and I repeatedly hit F5 again, we'll see that this load takes a lot longer because we're not able to access that stored data anymore. We don't have to wait for it, so we'll jump back into the presentation here. And so we'll talk about kind of the driving use case for the system, which is actually our A/B testing platform. So we built this in-house A/B testing system that supports hundreds of tests each day. And on average, every customer that's coming to our site gets assigned to a variety of these. There will be about 80 to 120 million pair assignments happening per day. And so we need to take all that data that's flowing in and essentially, for every one of the tests that's running, calculate a wide range of reports so that all our storefront engineers and PMs can know if their idea was actually a good one. So an example, is just the classic, we're trying to collect someone's email. Is it helpful to have a call to action that says save up to 70% off? Or should we just have them put in their email? So naturally, when this tool was built, we're like, we need some reporting on it. We should build it in a Tableau. But there were some pretty stringent requirements for that reporting. So we want to be able to provide context to the data that's coming. So if you see a falling add to cart rate across all of the variations, is that potentially driven by weekly or monthly or seasonal variation? And then we need to know, since A/B tests by their nature are changing things, they have a lot of, there's a strong possibility that they might end up breaking something. So we want to know, even if this isn't a direct, like this feature is broken, did we do something that is impacting the customer experience in such a way that we're just driving them off? And we want to know that quickly to avoid revenue impact. And then, even if we've done both those, we need it to be usable so that people actually look at it, get those insights, aren't trying to pull this on their own. And then once we have some results, we need to be able to dig in and kind of understand what was driving it. So that means that we unfortunately can't aggregate the data up too highly. We need to be able to kind of apply some arbitrary slices to it, be like, all right, is this because of people that saw this page and then went to this other page? Those kind of questions, which are hard to answer with aggregated data. So fortunately, this blended platform let us do all of that. So with Vertica, we can provide that full historical context. With MemSQL, we can provide that streaming data coming right out of the website. And Redis let us kind of say, all right, you had a great test, you're sharing that with the 30 other people in your department, that's okay. Things will still load quickly. And then Tableau is kind of the front end that glues it all together. So what are we going to do next? So the biggest thing we get asked is kind of, do you pre-cache data? And right now we don't. We just use the heuristic of if someone's loaded it, someone else is also likely to load it. And in particular, if someone's subscribed to it. Because we send subscriptions out when data sources are updated, which essentially warms the cache for that dashboard. But there's a lot of stuff that we could do. So we have this tool. We can see that, hey, someone's searching for this dashboard. They're probably going to get the most popular one. We can already start running those queries before they even load it. We can also do things with potentially, for our date-segmented stuff, even within Vertica, we don't update all our data all the time. We usually update, say, the last 4 days. So we can actually understand that a data set is split on a time grain. We can potentially cache portions of it and then reduce the amount that we actually need to hit the database for. The current system we have for querying across databases works, but it requires some configuration. It isn't very transparent. We'd love to have a better system for that. We're looking at Presto. We already have Spark. We just need to integrate it in. There's a lot more we can do with the servers. They're just get them on the latest and greatest, essentially. And then this also gives us the option to provide some configuration to what users are doing. We can say, hey, if you don't care about having the exact results, maybe you could run a sampled query on 10% of the database. We'll communicate that, feed it back to you, but you'll get a faster experience. And then right now there isn't a management UI because there's not a lot of management required. But there's a lot more that we want to do there, which it will be useful to have that for. And then obviously Tableau has some out-of-the-box R and Python integration that we'd love to be able to do more. We need to figure out how to fit that into this ecosystem. So that's pretty much it. Thanks for coming out. Now, questions.
Yeah, I'm curious. So Tableau has caching inside.
Yep.
So what does your caching layer give that the Tableau caches are doing?
Yeah, so the biggest thing there is knowing when the data is updated. That's where we add value. Because we have to set our Tableau cache pretty conservative, because we do have things that are just that aren't using the system that are, say, running against a SQL server, something like HR reporting. And they want 5-minute maximum. Whereas for some of these Vertica data sets, something like ad hoc exploration, we could actually keep that data around for 30 days or longer because we know exactly when the table's being changed.
So if you have more granularity in Tableau's caching schemes, you'd probably be able to. What about cache size?
Yeah.
Cache a lot bigger?
It's not. We don't cache anything that's over 500 megabytes, and we find that not a lot exceeds that. So cache size hasn't been a big concern. If we could hook in more granularly to Tableau's caching, then yeah, absolutely. It's just, yeah, it's essentially that ability to say we've got these associated keys. Yeah.
What is the size of your Vertica cluster?
We have 250 terabytes of data total, 22 node cluster currently, and we're going to be moving up to 30 nodes soon. Anyone else? All right, thank you again. I'm supposed to share this slide.